Alright, so we are working through exercise 5e, which is all about multiplying and dividing expressions, our learning intentions, to know the different ways multiplication and division can be written, to be able to simplify expressions with multiplication, and to be able to simplify expressions with division. The first thing we're going to do is a bit of a refresh. So we've gone through this previously, and it's writing expressions without the multiplication sign. So right here, what we're going to do is we're going to write this, but without the multiplication sign. So remember, in algebra, we really don't like this symbol. We much prefer to write it like this. When we come over here, y times 27, remember the number always goes first, and then you just put the pronumeral right next to it. You don't need the multiplication sign. It's almost like it's invisible. Whenever you see two things next to each other, you just know they're being multiplied in algebra. And lastly, here we put the number first, and then the pronumerals, we just put them next to each other beside it. So we've seen all this stuff before, and in today's lesson, we're really going to be building on it. Okay, so the first thing we have to do is simplify these expressions. So the instructions are simplify the following. And as you can see here, we have 4 times a times 2 times c. So what we want to do here is get rid of those multiplication signs. Now, hopefully you can notice that we have two numbers and we also have two pronumerals. So the very first thing I'm going to do is I'm going to write my two numbers next to each other and the two pronumerals next to each other. Remember the property of multiplication, that you can do it in any order. So what I mean by that is 3 times 4 is the same thing as 4 times 3. So the fact that I have moved these around hasn't changed anything. Now, what is 4 times 2? Well, 4 times 2 is 8. And then I'm just going to bring this part right down. And now I have 8 times a times c. And we know we can just write that like this. So what we have just done here is we multiplied together the numbers, and then the pronumerals, we just put them next to each other. Let's go through another example. So here we have 3 times 4w. The first thing we're actually going to do here is I'm going to put back in that multiplication symbol between the 4 and the w. So if I was to rewrite this whole thing, it's 3 times 4 times w, because remember, invisible between this 4 and w is a multiplication sign. Now I can go, well, what's 3 times 4? Well, 3 times 4 is 12, and then I'm just going to bring this times w down as well, and I know I can write this as just 12w, and that's my answer. Let's go on to the next one now. And again, what I'm going to do is I'm going to put in those invisible multiplication signs. So I know there's a multiplication sign between the 4 and the a, so it's going to be 4 times a, then I've got this times, and then it's going to be 2 times b. And once again, I'm going to bring together my two numbers, the 4 and the 2. So 4 times 2, and then my pronumerals, I put those at the end. Now I can go 4 times 2 is 8. Then I've got times a times b. So it's going to be 8ab, just like that. Hopefully you've started to notice something. All we're doing here is we're going multiply the numbers together. So 4 times 2 is 8, and then put the pronumerals next to each other. So that means we could answer this one right here, our next example, very quickly. We could go 3 times 2 is 6, 6 times 5 is 30, and now I have A, B, and C. I'll put them all next to each other, and that is going to be my answer. Now, if you're thinking, wow, that was way too fast for me, that's fine. You can go through it the slower way in which you're adding in those multiplication symbols. So this 3a, we know that's 3 times a, that I've got this multiplication sign. This 2bc is 2 times b times c, and then I've got times 5 here. Then remember what you're doing is you're putting all the multiplications next to each other, 3 times 2 times 5, and all the pronumerals next to each other, a times b times c. Then you're going 3 times 2 is 6, times 5 is 30, times a times b times c, and then you go from there to there. But hopefully you can also appreciate that it's a lot quicker just going straight to the answer. You just got to realize that you multiply together the numbers, and then you multiply together the pronumerals. Okay, let's do some more examples here, and we're going to introduce some powers as well. So again, the instructions here are simplify the following. Now, when we have a times a, what is that equal to? Well, that's equal to a squared. Remember, if I had 2 times 2, that's equal to 2 squared. That's what it means, and that's equal to 4 in this case. So whenever you've got the same pronumeral multiplied by each other, it's just that pronumeral raised to the power of 2. Now, I want to make a quick note here because there's a mistake that people often make here. So I'm just going to rule off a bit of space here. If I have a plus a, that's equal to 2a. But if I have a times a, that is equal to a squared. People all the time get these two things confused. The difference between plussing the same pronumeral together and multiplying the same pronumeral together. So you should know this. Okay, let's keep on going now. Here we have 3t times t. Well, let's use the same procedure we did up above. We know there's an invisible multiplication sign between the 3 and the t. And now I can go, well, this is 3 times t is t squared, which means my final answer is 3t squared, just like that. Let's go on to the next one here. This is 3 times k times 4 times k. I put my numbers next to each other. I put my pronumerals next to each other. 3 times 4 is 12. And then k times k is k to this 2, k squared, or k to the power of 2. And that is our answer there. Now, hopefully you can realize we can start doing this a lot quicker. We can just go, oh, I've got 6, I've got 2, that's 12. And then I've got 1h, and I've got 2 t's, so that's t squared. If you're still finding that a bit too fast, just take your time with it. Put in those multiplication signs. Then bring together the numbers. And I'm going to bring together the t's as well. And now you can see I have 2 t's, which is giving me t squared. I have 1h, which is giving me a h there. Then I've got 6 times 2, which is 12. And that's my answer. Let's keep on working. Okay. Last a few examples of this page, and we're going to go through this the way that I hope that you'll be working through them with enough practice. And that's by going, all right, I have a 3 here, I have a 2 here. 3 times 2 is 6. Then I have 1a, I have 1b, I have 1c, and I have 1g. That is going to be my answer. So I multiplied together the numbers, then I put all my pronumerals next to each other. Next, we have 5. We have 5, 2, and 3 as my numbers. 5 times 2 is 10, times 3 is 30. Then I have 1a, I have 1b, I have 1c, and I have 2 f's. So that means I have f squared, because it's f times f. So that is my answer to the next one. Whoops, let's see if I can do that a bit better. Okay, let's come to this one now. Remember, I'm going to multiply together the numbers. So it's 4 times 2 times 2. 4 times 2 is 8. 8 times 2 is 16. And I have 2 t's. I have 2 t's, so that's t squared. And I have 1k, so just a k by itself there. Perfect. Last example. Here, wow, we have a lot of numbers here. We have 3 times 2. 3 times 2 is 6. 6 times 4 is 24. 24 times 2 is 48. And then I have 1a. I have 2 b's, so that's b squared. And I have 2 c's, that's c squared. So that's my answer. And 3 times 2 is 6, times 4, 24. Okay, that looks good. Perfect. So that is everything we're going to talk about today in regards to multiplication. Let's now move on to our next idea, which is division. And again, we'll start off with something we've seen before. So, removing the division symbol. So, write the following without the division symbols. So, we've seen this before. In algebra, we don't like that division symbol. So, instead of writing 5 divided by x, we write 5 over x. Over here, we have to be careful. Again, we want to remove this division symbol. But do you see how we have brackets here? The brackets means that this thing right here is one entity. It's one thing. So if I have 2 divided by this, it's going to be 2 divided by 7x minus 1. Let's come to the next one here. Again, because of the brackets, this is one thing. So my answer is going to be 3x plus 1 divided by 5. And last but not least, here, this is going to be 3x plus 2 over 2x plus 1. So those are your answers for those questions. So pretty simple idea there, nothing too tricky. You just need to make sure that you're not writing that division sign, but rather writing it like this, and also be aware of those brackets. Okay, now we come to something that might be a little tricky, and that is simplifying non-algebraic fractions, and later on we'll simplify some algebraic fractions. But first, let's just deal with some non-algebraic ones. And what I mean by that is that all these fractions don't have pro-numerals. Okay, let's read this. When dividing any common factor in the numerator and denominator must be cancelled. Simplify the following. Okay, so how are we going to approach this? Well, if I have 5 over 10, hopefully a lot of you know, well, that's the same thing as a half. But how exactly does that work? How did we go from this to a half? We know that 5 over 10 is a half, but how did we do that? Well, what we're doing is we're actually cancelling out common factors. So I could write 5 as 1 times 5, and I could write 10 as 2 times 5. Because 2 times 5 is 10 and 1 times 5 is 5. I can now cancel out those two 5s because they're both in my numerator and my denominator. And that's exactly what this thing says up here. When dividing, any common factor in the numerator and denominator must be cancelled. So I can get rid of those 5s. Now, what does that leave me with? That leaves me with a 1 and 2 in the denominator. So 1 in the numerator and 2 in the denominator. And that's how I got 1 here and 2 here. So that is how it works. We're just cancelling out any common factors in my numerator and denominator. Let's do the next one. All right, so if I have 3 and 15, I can write 3 as 1 times 3, and I can write 15 as 3 times 5. Now, that's good because 3's are both in my numerator and denominator, so I can get rid of those. And that means I have a 1 in my numerator, and I have a 5 in my denominator. So that means 3 on 15 can be simplified into 1 on 5, just as 5/10 can be simplified into 1/2. All right, let's keep on going. Next, so again, what we're going to do here is we're going to take 6 and we're going to break it up into factors. So how about 2 and 3? We're also going to take 8 and break that up into factors. How about 4 and 2? Well, if I do that, this 2 will cancel out with this 2, and what I'm left with is 3 on 4, and that's my answer. Let's move on to the next one. Here I have 8 on 12. Well, 8 can be broken down into 2 and 4, and 12 can be broken down into 2 and 6. So that means this 2 will cancel out with this 2, and what I'll be left with is 4 on 6. Now, we have to be careful here. Could I break this 4 and 6 into more factors? I could keep breaking this down into factors. 4 can be 2 times 2, and 6 can be 2 times 3. So that means this 2 will cancel with this 2, and I'll be left with 2 on 3. Now, can I keep breaking this down? Could I break 2 and 3 up even more? And the answer to that is not really. We could go 2 times 1 and 3 times 1. But if I was to do that, those 1s would go away, and I would be left with 2 on 3 again. So nothing really changed. So let's get rid of that. That is as far as I can go. And what you should notice here is that it actually took me 2 steps. I cancelled here, and then I had to cancel again. This is perfectly fine, but it's always best just to do it in one shot. So I'm going to rewrite 8 on 12, and we're going to see if we can simplify this in one shot. So 8 I'm going to break down into 2 and 4 again, as I did up here. But instead of breaking 12 into 2 and 6, I'm instead going to break it up into 3 and 4. And now that 4 can cancel out with that 4, and I'll be left with 2 on 3. So what I've done there is I have cancelled with my highest common factor. My highest common factor of 8 and 12 is 4. So that's how it's working. But it's important for you to know that both of these are legitimate ways to do it. And although this one is preferred, the bottom one here, there's nothing wrong with this one. Okay, let's keep on working now. All right, so here we have 12 and 20. You might want to pause the video and give these a go for yourself. So what I'm going to do here is take 12 and break it up. Let's break it up into 2 and 6. And I'm going to break up 20 into 2 and 10. Now, if I was to do that, these 2's are going to go away with each other, and I'm going to be left with 6 on 10. But similar to this problem, I could keep on breaking this down into common factors. So this could be 2 and 3, and this could be 2 and 5, in which case this 2 and this 2 will cancel, and I'll be left with 3 on 5 as my final answer. Again, this took me 2 steps to complete. I prefer to do it in 1 step, so let's rewrite it and see if I can do it in 1 step. 12 on 2. Well, what could that be broken down into? That could be broken down into 3 and 4. And 20 could be broken down into, what could 20 be broken down to? 4 and 5. In which case, this 4 and this 4 will cancel, and I'll be left with 3 in my numerator and 5 in my denominator. And as you can see, that's a quicker way to do it. But again, both ways are perfectly legitimate. All right, last one, 14 and 56. 14 can be broken down into 2 and 7, and 56 can be broken down into, what's that going to be? I think it's going to be 8 and 7. So this 7 will cancel with this, then I'll be left with 2 on 8, and then from 2 on 8, I could say this could be broken down even more. This could be 2 times 1, and this could be 2 times 4, in which case these 2's will go away, and I'll be left with 1 on 4 as my answer. Now, there is a quicker way for you to do this. You could go 14 on 56 is the same thing as 1 times 14, and then this will be 4 times 14, in which case this 14's will go away and you'll be left with 1 on 4. I actually think in this case, this is the better way to go about it, because not many people know their 14 times tables, and I think that's fair enough. I don't think it's appropriate that everyone know their 14 times tables. Okay, so there is a very important idea there, simplifying non-algebraic fractions, so fractions without pronumerals. Now, let's just quickly go through these very last examples here before we turn the page. Simplify the following. Remember that a over 1 is equal to a, so that's important here. So we're going to approach these the same way we did above. 4 over 2. Well, that's 2 times 2, and then on the bottom here, I could say this is 2 times 1. 2 times 2 is 4, 2 times 1 is 2. Now this 2 and this 2 will cancel, and I'll be left with 2 on 1. And 2 on 1, well, what's 2 divided by 1? It's just 2. And that's exactly what this is telling us. A over 1 is equal to A. So whenever you have a number divided by 1, it's just going to be that number. Let's come over to our next one here. 9 could be broken down into 3 times 3. And 3 is just 3 times 1, in which case these 3's will cancel. I'll be left with 3 over 1. So therefore my answer is just going to be 3. Next, we have 28. Well, 28 can be broken down into 4 and 7. And 7 here can be broken down into 7 times 1. 7 and 7 go away, and I'm just going to be left with 4 over 1, which is just 4. Actually, let me write that down. 4 over 1, which is equal to 4. So all we're doing here is we're saying 28 divided by 7 is 4, but you've just got to realize it's a whole number. It's no longer a fraction. And then the last one here, let's make this 6 times 6 over 6 times 1. These cancel, and I'm going to be left with 6 over 1, which is 6. Perfect. Let's keep on moving. Okay, so now having talked about non-algebraic fractions, and I know this is a long lesson, but stay with me. We're now going to go through algebraic fractions. Okay, so exactly the same principle is going to apply. So as we come here, we could say, all right, I have A times C, and on my bottom here, I have A times B. Now, these A's are in common, so I can cancel those out, which just leaves me with CB. We come over here, xy over xz, well, that's x times y over x times z, in which case this x and this x are in common, so I have y over z remaining. Now, it kind of is a bit pointless writing it as x times y, adding in that multiplication. What I would prefer you to be able to do is just go, I have an S here, I have an S here, and therefore I just have R over U. So what I really want you to be able to do is to look at this and go, I have an X here, I have an X here, so therefore I'm just left with Y on Z. That is what I hope you can do. All right, let's keep on going. Here, let's break it up into our multiplication. So my denominator here will be X times Y. Now, what could I break up this x into? Well, this x could be x times 1, which means this x and this x will go away, which will leave me with 1 over y. So it's important to realize that when we get rid of everything in the numerator, because we've cancelled, there's always still a 1 there. So let's come here for a moment. If I was to go, well, this a cancels with this a, this b cancels with this b, this c cancels with this c. So that means I have d in the denominator, but what do I have in my numerator? It looks like I have nothing, but remember, there's always a 1 there. There's always a 1 there. All right, let's come to our last one here. This k will cancel with this k. This j will cancel with this j. This l will cancel with this l. So that means I only have p left. And remember, when I have nothing on my numerator, that just means there's 1 there. All right, let's keep on going. So here, this k will cancel with this k, which means I have h here. And remember, the same idea is going to apply. So I might actually do this a bit slower. This will be h times k, and this will be k times 1. So this k will cancel out with this k, and I'll be left with h over 1. And we know that whenever we have anything divided by 1, our answer is just going to be what's on top. So h in this case. And the same thing is going to apply here. This n will cancel with this n, this l will cancel with this l. So that means I'm going to be left with just this m on top. So m over 1 is equal to m. And for our last one here, exactly the same idea. This e cancels with this e, this f cancels with this f, which means I just have a d left in my numerator, which just means my answer is d. Okay, so having now seen both this and all of these, let's now go on to the main event, which is simplifying algebraic fractions. So these here combine both numbers and pronumerals. So you have to be comfortable with both of them. All right, let's go. So we know that if you're having trouble with this, you can actually add in those multiplication signs if they help. So this right here is 3 times a over 7 times a. And those will cancel, which just leaves us with 3 and 7. So 3 on 7. And that would be our answer. We come to our next one. We know that this n is going to cancel with this n. So that means I'm just going to be left with nm on top and 4 on the bottom. Perfect. Let's come over here. All right, so this is where we're kind of, let me circle that. This is where we're combining a few things that we have seen. So I can break this 4 up into factors. 4 is the same thing as 2 times 2. And then I've got this x as well. And then this 8 here could be broken down into 2 times 4. Or how could we break that down? I mean, we could break it down more, but I just want to leave it like that. Actually, you know what I'll do? Actually, let's leave it there. All right, 2 times 4, and then I've got an x here as well. Okay, so that means this x will die with this x, this 2 with this 2, which means I'll be left with 2 on 4. Now, 2 on 4 can be further simplified. 2 on 4 is the same thing as 2 times 1, and 4 is 2 times 2. So those 2's would go away, and I'd be left with a half. The other way that I think is probably a far more efficient way to answer this question is to simply leave that 4 on top, and then say 8 can be broken down into 2 and 4 and x. The x's will go away, the 4's will go away. We know that when we have nothing left on the numerator, there's a 1 there, and I've got 2 in my denominator. And that's a far better way to answer that question. Let's come here now. Here I have 7 times a over, now this is 21. 21 can be broken down into 7 times 3 times, and I've got this b as well. So that means this 7 will go away with this 7. I can't cancel out the pronumerals because they're different, which means I'm going to be left with a over 3b, and that's going to be my answer. All right, let's keep on moving. Only a few more examples here. Here I have 20 xy over 2y. Well, 20 can be broken down into 2 times 10. Then I've got times x times y over 2y is the same thing as 2 times y. So that means this 2 will cancel off with this 2 and this y with this y, which means I'm going to be left with just 10x on the top over, now when I have nothing left in my denominator, I know there's just going to be a 1 there. So that means my answer is going to be 10x. 10x, I'm going to give that a circle. All right, let's come to our next one here, which is 28 over 7. This looks familiar to the top. Oh no, it's different. Okay, so this will be, all right, so I want to break off this 28. This 28 can be 4 times 7 times A times B over 7 times A times C. This A will cancel with this A. This 7 will cancel with this 7, which means I'll be left with 4 and B on top, and I'll be left with C on the bottom. Let's keep on going here. You might, looking at this, immediately just want to get rid of those K's. Just get rid of them. And then we can say, I'm just left with 50 and 60. Well, 50 is the same thing as 5 times 10. 60 is the same thing as 6 times 10. Those 10s go away, which is going to leave me with 5 over 6. We come over here. You can immediately see that B is going to cancel with that B. And now I just have to figure out how my numbers are going to break down. Well, this 27 is the same thing as 9 times 3. And remember, I still have this A here. And then on the bottom here, I have 18, which is the same thing as 9 times 2. And I still have a C there. So these 9s are going to go away with each other. And I'm going to be left with 3A over 2C. And that's going to be my answer there. Last ones. All right, 16xy over 8y. How are we going to answer this? So this is going to be, those y's are going to go away with each other. Then I can say that this 16 is the same thing as 8 times 2, and I still have a times x here. And then this 8 is the same, oh, let's just leave that 8 there, because we can then cancel it with that, and I'm just left with 2x. And remember, it's 2x over 1, which is the same thing as 2x. And then lastly, very last one, this p will cancel with this p, which will leave me with 24 is the same thing as 6 times 4 times m times n over 6. This 6 will cancel with that, and I'll be left with 4mn, and that will be my answer. Perfect. All right, so we've gone through a lot of examples here. I wanted to do that because this is a concept that people find tricky many times. So with that being said, hopefully you found this useful, and I will see you in the next lesson.